There comes a time in every ACE's career when he must face a challenge. These challenges can vary for each individual, however, there's always one task that haunts junior ACEs, and that is what this video sets out to explain. My name is Nicholas Vassos, and today I will be going over the basics of soldering. Before we solder, a well-needed introduction into the tools and techniques for this task is required. So, what is soldering? Well, let me explain. At this point in your ACES career, you should be familiar with breadboards. Breadboards have holes in them that bridge components together. Breadboards are not the only type of board available for use, however. For a more permanent placement of components, we use special boards. For example, this board here is called a perma-proto board. The alignment of the holes is exactly the same as a breadboard, yet the holes are different in size. In simplest terms, the process of soldering is to use a heated device to melt metal wire onto components so that they stick in the board permanently. Before we solder, we should familiarize ourselves with these components. First, the soldering station. These beasts are found all over the DES and are pretty simple to use. When on, there are two states, set and read. Flick the switch to the set side first and change the dial so the number is around 300. This means that the metal rod will heat up to around 300 degrees Celsius, enough to melt the solder. When that's done, flick the switch to read and the rod will begin to heat up. While that's heating up, let's look at these guys, helping hands. These clips here attach to a device or board to hold it in place. If a component needs to be held down though, reverse tweezers will do the trick. Alright, we're at 300 degrees. Now it's time to solder. The name solder refers to the metal wire that will be melted onto components. This wire burns very easily, so be careful with how you use it. While soldering, there are a lot of fumes. That's where the fume hood comes in. Always turn one of these on nearby before you begin. Now, when choosing which component to solder, always start with the smallest things of least importance, probably starting with resistors and ending with big things like capacitors. Resistors aren't polarized, so it doesn't matter which way you put them in. Now that we have our first component in place on our board, we are ready to start. Here is a step-by-step for your first ever soldering job. First, turn on the fume hood. Then take the soldering pen out of the station. Make sure it works by burning some solder in front of you. To yield good results, the tip must be clean. To do this, the soldering pen should be dipped in this brass wool. This process is nerve-wracking. After all, you do have a hot metal stick in your hand. Just don't freak out if your hands shake. Take a deep breath. With our first resistor held in place, simply apply the heat near the lead, put the solder into it, let it surround the component, and take both of them away. This process should take no longer than 5 seconds. This has to be quick, as the heat might damage the components or even the board. There you go, that's your first component. Now that you have a feel for soldering, try with the other small components. In this case, I soldered the other resistors to this board. When you are finished soldering these components, grab some safety goggles. When looking at the board, the leads of the resistors are still poking out. We don't want that, so we have to cut the leads off. That's where these guys come in. These safety goggles are necessary as the leads fly in all sorts of directions when cut. After the leads are cut, the component is perfect. Let's move on to the next thing, LEDs. LEDs are polarized, so you have to solder them in the right way. The side with the line indicates negative or the shorter lead on the LED. Now that the LED is in the holes, we run into a problem. LEDs cannot be held easily with the reverse tweezers due to the dome-like shape on the top. I wouldn't recommend holding the component down with your other hand, at least for now. For this job, I bent the leads so that the LED stays in place. Now it's the same process as before. Turn on the fume hood, take the soldering pen out of the station, burn some solder in front of you, dip it in the brass wool here, take a deep breath, apply heat near the lead, put the solder into it, let it surround the component, and take both of them away. This process once again should take no longer than 5 seconds. Repeat this process with the other LED, and snip the leads. This is what the board should look like with the resistors and LEDs in place. Now it's time for the buttons. It doesn't really matter which way you put them in, so it's pretty easy. And the process is same as before, yada 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 yada. When finished, the leads are actually really small anyways, so you don't even need to cut them. Easy. Finally, let's move on to the big boy, the capacitor in the middle. Capacitors are polarized, so you do have to solder them in the right way. There is a little plus here for the longer lead, pretty self-explanatory. At this point, you're pretty much a pro, and you can handle this one on your own. At this point, you have everything except power. This 3D printed case provided with your board comes with power. The red or positive lead goes in here, and the black or negative lead goes in here. That is a conversation for another day. Yes, you are soldering in backwards, but that is what you are supposed to do as we are screwing the board down later. The metal ovals around the leads make it even easier to solder as the melted solder just goes around there. Easy. Now you have the final soldered board. After screwing it into place, the board is done and ready for use. Keep in mind that the board should be screwed in so that power is away from your hands. I will give you an extremely brief lesson on how this circuit works. When this button is pressed, the capacitor in the middle fills up with charge. This is shown with the bicolor LED. When it's faded, you know the capacitor is full of charge. By letting go, the capacitor releases its charge the other way, hence the changing color of the LED, and the button on the right discharges it to be used again. That was a brief introduction to soldering. Your hands will shake. You will probably mess up, but that's okay. Like most things, you will only get better at soldering the more you do it. Soldering opens up a whole new world of possibilities. Now, it may be difficult, but with a community of boys around you and the DES at your disposal, it is only a matter of time before you become a true pro.